Hi, everybody. Sorry for the technical issues, but here we are. Thank you for coming. Today, I'm going to show a technical overview of Morph L2. I was supposed to show how to deploy your first smart contract, but I'm going to skip that because I can't use my computer. So let's get started. So this is the agenda. We're gonna see what is Morph, the technical side, our sequencer network, our batching and submission contract, our responsibility proof, how we combine the hybrid method between optimistic and CK, and the roadmap, how we're approaching to mainnet by the next few months. So yeah, let's get started. This is me. I'm Abriel, developer relations at Morph. Previously, I was working as a Solidity engineer in DeFi mostly, and now I'm working as a DevRel, and I would say it's more fun. So, who in this room know about Morph? No one. Okay, this is good. So we have a lot to talk about. Just you. Okay. So first of all, um, we are Ethereum L2. That basically we combine optimistic CKVM, and a lot of people ask how that can happen and why we are approaching in that way. We're also a consumer-centric blockchain, so we know that there's a lot of infra projects, but not really consumer applications. So we really want to focus on bringing more consumer apps to on-chain. So that's why we are focusing on consumer applications. We actually have a track in this hackathon for consumer-centric applications. And we are also very collaborative. We have a very collaborative ecosystem. We are giving a lot of different initiatives for our long-term builders, especially in this stage because we are in testnet Holsky B2. We launch in January. And so, yeah, let's get started to review the technical overview. So we basically have the centralized sequencer network. We have a hybrid rollup, OP meets CK. We are approaching to have a fully CK rollup after mainnet. And we have a modular design. Let's talk about our decentralized sequencer network. So sequencers are responsible for producing new blocks in L2s, right? So imagine that a sequencer is a group of participants who have a special job, which is basically produce and confirm new blocks to send all of the transactions to the main L1, which in this case is Ethereum. Think of a block like a page in a ledger book for digital transactions, right? To join this group, participants need to basically put down some ETH as a kind of promise, and this is a chaos. So this is the whole diagram. So the participants need to basically put down some ETH, and this is done through our staking contract. Then they go through an election to become a sequencer, which we will open right now we are running 7 sequencers on testnet, but we will open for partners after mainnet, and they will need to go through this staking election process. It's basically, this is a way to make sure that only serious and committed participants get to do basically this job. Once they're part of the sequencer set, their main task is to take all of the transactions that haven't been confirmed and put them into blocks. Then they work together to check and agree that everything in those blocks is correct. Basically, they use a method called Tendermint, which you will see consensus Tendermint. And it's basically a way to agree. It's like a straightforward way for all the sequencers to make sure that they're all seeing the same transactions in the same order. I would say this helps the network be more secure and run more smoothly and fast. And also, after they agree on the transactions, these are officially recorded onto the main L1. This process helps the network basically handle all of the transactions in a fastest way. And this is the layer 2 blocks generation. So following the VFT consensus protocol, the selected sequencer extracts all of the transactions from the mempool and constructs the blocks and synchronize all of these blocks with other sequencers to go through the verification and voting. The end result is basically the generation of the new L2 blocks. Basically, this is the sequencer set, and this is basically blockchain networks to manage the transactions and to help process all of the transactions. This involves basically a technique called batching, using something known as a batch submitter. So normally, each block of transactions will be sent to the L1, and this can be, I would say, pretty slow and expensive. As we know, Ethereum is pretty expensive. So basically, to solve this, sequencers, those special participants that we talk about, use basically a strategy. They group several blocks of transactions together into what we call a batch. And so at certain points in time, these checkpoints, the sequencers take all of the blocks that they've gathered and sync them off together using a digital signatures, which is the BLES signature. This is a way to ensure that all of the transactions in the batch are valid and agreed upon. And so they use a specific, this signature can be also somehow expensive, but once the batch is signed, it's not sent to just any part of the blockchain. It goes to a special part of the main blockchain through something known as a roll-up smart contract. And so this is like a gatekeeper that checks, I would say, checks and processes these batches. And the job of the selected sequencer is to send three things to the layer 1 contract. The combined signature for the whole batch, like you can see here, and they pack all blocks between these two blocks with a signature into one batch and then submit it to the layer 1. When the layer 1 receives this, checks all of the submitter signature to make sure that it matches with the transactions. And by signing off on a batch of transactions and sending all of the transactions to the roll-up smart contract, this process ensures that the network is more efficient, scalable, and also it accommodates all of the transactions in a secure way because they're validating all of them into the layer 1. Now we will talk about, okay, how we actually are an optimistic and CK rollup, because everyone asked that, okay, why we aren't a fully CK rollup yet. So the process is basically based on the validators will need to constantly verify all of the transactions to basically new state sequencers submitted that have already submitted to the layer 1. Then, if they find the transactions and the states are not correct, they will initiate a challenge. Then, the sequencers need to answer the challenge by providing a CK proof and pass the verification process, basically. And if the sequencer can't really finish the verification process during a certain period of time, the fraud behavior is settled. So that's how we integrate the fraud proof. The validators, of course, will need to stake in order to initiate a challenge in this case. And this is, I would say, our main, because right now integrate a fully CK rollup can be pretty expensive. That's why we're integrating like hybrid method. And so we are expecting by mainnet, after mainnet to integrate a fully CK rollup, we will have Morph staking. We will launch in mainnet, our token. We have also some updates by the end of the year, layer 3 support, and Alcan abstraction. And so right now, what we're looking for is to bring more apps, more consumer apps on chain in a way that I would say my main goal is to onboard more developers to build actual use cases, right? We are seeing a lot of investors putting a lot of money into infra, but not really into apps that, in a way, will bring the 1 billion users to crypto, right? And that's just something that we want to achieve, and we're just getting started. And yes, just go through our booth. We are giving 7K USD in prices for the consumer track, and innovation track we are giving 3K. You can build whatever is innovative and it can surprise us, can be AI on-chain apps, developer tooling, something that can help the network also be more scalable. We're looking to support all of our long-term builders. We are also giving grants for if you're building on testnet or even if you want to build on mainnet. So yeah, just come by, and I hope everything was clear here. And yeah, if you have any questions, please let us know. Here's our engineer that will also help with the questions. And yeah. Someone has any questions? No one has questions. Uh-huh. So we are going to, no, no problem. We're going to mainnet in mid-August. We're auditing smart contracts right now, so it can take a little bit of time. But yeah, we're going in mid-August, September. No more questions? No, okay. That's a good question. So we actually onboard a really cool consumer app called Lemon. They win our incubator program. They are building like an education on chain. You can get rewards to learn different programming languages. It's like a Duolingo on chain, but for learning different programming languages. And I think that's really, really cool. And that's the type of consumer app that we want to see on board, honestly. But also some use case that I'm really bullish on because I've been experiencing is basically on-chain payments. So if you want to build something around payments, stable coins, on Morph, come hack with us. So yeah. Okay. Thank you so much.
Okay, thank you. Woohoo! Sorry for the wait, guys. Right, shall I start? Yep, cool. All right, thanks for coming and joining us. Sorry for the delay, always some technical issues. But in the next session, we'll be talking about building EVM dApps on Bitcoin with Rootstock. My name is Olya. I lead developer experience at Rootstock Labs. You can find me fairly easily on most socials at Olya Dukova, with an exception for Discord, which is ETHGlobal. So feel free to reach out to me if you have any questions or need any support, technical or otherwise, with whatever you're building. I've done a couple of, I've come as a hacker to a couple of ETHGlobal events, and this is the first time we're bringing Rootstock to this event, so I'm super excited. All right, so in this 20-minute session, we'll cover a few things. Mainly, I'll give a short introduction to Rootstock architecture. We'll have a look at the ecosystem, smart contracts and dApp development, and development tooling and resources that will help you building on Rootstock. And then I'll share a little bit about a recent project that we've been working internally on with our developer experience team. All right, so let's start. What is Rootstock? Rootstock is a Bitcoin sidechain. It's the first and longest running, so the OG Bitcoin sidechain. We've been in main net since 2018, so for about 6 years now, with 100% uptime, which we are very proud of. What makes Rootstock special is that it's fully EVM compatible. So builders can write smart contracts in Solidity, and all the developer tooling will work as it would have worked on any other EVM compatible chain. So I'll dive into it a little bit later. And finally, Rootstock is secured by merge mining. So it's merge mined with Bitcoin, and I'll explain how that works in the next couple of slides. A little dive into the architecture. So RSKJ, it stands for Rootstock Java. Is the node, is the main component of the chain. It was originally forked from Ethereum J. You can find the implementation on GitHub. It's open source under a license. We do welcome community contributions via pull requests on GitHub. So if you're interested, you can check that out. Also, the RSK white paper is available on the website, which is rootstock.io. RSK IPs, so Rootstock improvement proposals, very similar to EIPs. Open source on GitHub. It's basically a bunch of markdown files that everybody can go and check out under the CCO license. And there's also a forum for those discussions. It's kind of like just a bit more user-friendly. It's categorized, so if anybody's interested. Right, let's have a look at how Rootstock is connected to Bitcoin. I mentioned merge mining at the start of my talk. Merge mining was not invented by the team, Rootstock Labs, or anything. It exists as a method. There are a bunch of other networks that use it, but as I mentioned earlier, Rootstock is the most successful project being merge mined with Bitcoin that's ever been out there. So the way it works is that Bitcoin miners, they include the change of state of the Rootstock network in the Bitcoin block header. And the difficulty of the cryptographic puzzle that is needed for the Rootstock chain is lower than is needed for the Bitcoin chain. Hence, some of the headers that do not solve the puzzle for Bitcoin are still valid solutions for the Rootstock network. You can check out more about how merge mining works. It's quite interesting on the site and read about more the architecture, but that's pretty much, I think, all you need to know at this point. The other way we can describe Rootstock connection to Bitcoin network is also through cryptocurrency. So Rootstock is not subsidized. We do not have a separate token. So the gas fees on Rootstock networks are paid in RBTC, which stands for Smart BTC. It's basically, you can think about it as a wrapped version of BTC. The bridge used for that is called PowerPeg, so proof of work peg. And basically, it's a federation bridge secured by proof of work and HSMs. So the way it works is basically it provides bidirectional conversions between BTC and RBTC at the one-to-one exchange. Again, there's more kind of information about it in the docs if you're interested in that kind of stuff. Now, let's have a look at the rootstock connection with Ethereum. That's why we're here. The RVM, which stands for Rootstock Virtual Machine, basically uses the same opcodes as EVM, which makes it fully EVM compatible. So all the Solidity code, all the smart contracts can be executed by RVM. So not just you can write your code in Solidity, your smart contracts, you can also use all the tooling that you're already used to. So if you've been developing in the space, so dev frameworks like Hat, Foundry, WAGMI, you name it, everything will work. And then from the user kind of perspective, also the rootstock node exposes the same JSON RPC interface as a Ethereum node would, so you can also easily port dApps from Ethereum compatible chains with just a slight change in configuration. Cool. RIF. So RIF stands for Rootstock Infrastructure Framework. It is a bunch of apps and services you can find in our docs. Cool, thank you. That basically will make it easier for you to build on top of Rootstock. They include things like wallet, the RNS. I encourage you to check that out. There's also an RPC API. You can find it at rpc.rootstock.io, and the Explorer to kind of monitor on testnet while you develop an app. So that's all in the docs. There's a few facts on here. I'm not going to dive into them because I don't think I have much time. But I mentioned most of these things to you already. Something I didn't say about merge mining is that it's almost 60%. So it's roughly of Bitcoin hash rate is used to secure Rootstock network also, so a lot. Cool, this is the ecosystem slide. Again, not going to dive in, I don't have much time. Feels like a needed slide in any crypto presentation. Right, so these are the tools I mentioned earlier. So you can see on different levels, so smart contract, DevTools and client-side libraries also due to EVM opcode level compatibility, JSON RPC compatibility. I've put a few logos for you here. You probably recognize there is a few integrations that we have that will again help you build. We've got ThirdWeb, Gelato for contract automation, EtherSpot for account abstraction, Crypto.do is the no-code, low-code solution, Covalent, Tenderly, Blockscat, etc. I had a little demo here on how to build a dApp on Rootstock and 3 easy steps. It's very bare bones, super basic, but just wanted to show you quickly how easy it is. It's also very ugly, and I apologize for the slides, they're also ugly. I hope our designer never sees them. But basically, we need Node.js, MetaMask configured for Rootstock, and test our BTC, which you get from the faucet. If you have any problems, please find our team, and we'll give you TRBTC. And then Hat, Solidity, React, and ETHGlobal. I'm sure you guys are familiar with all of this. I'm not going to dive into it. So creating a smart contract, we initialize Hat projects and Hat, install dependencies, and then we create .env file where we store the private key. So all pretty basic. Then a smart contract in Solidity. This is very basic. It basically just takes a vote for your favorite smart contract programming language. And then we update the Hat config file with a rootstock URL, create deployment script, and that's pretty much it. We compile and deploy, and it should work. This is the hardest bit, is the front end. This is in React. I'm a rubbish React developer, but it still works. I'll run you through it. So we create the app, install ETHGlobal for interaction with the chain, create the voting component. This is the longest file in the whole repo. I'm not going to dive into it. It's fairly basic also. So then we update the app component, update index file. This step is important. Add your contract API from the Hat project. And then we start the application, npm start. So that's what we should have. I'll try to show you quickly if that will work. I'm not sure. Here we go. So we vote, let's say Solidity, confirm. And spending, it will take 28 seconds. Maybe we can come back to it. We can have a look at this at the end, I guess, if we have time. All right, what else we have? Something I wanted to mention, we do have a separate bounty for runes on rootstock. Our DevX team have recently built a kind of a proof of concept for the bridge, rune store bridge. So it kind of has the basic functionality of minting runes on Bitcoin, bridging to rootstock, minting on rootstock, reverse bridging. There is a QR code if you're interested for the GitHub repo to explore this, and I've provided a couple of ideas of what can be built. So basically integrating runes into DEX, building a marketplace, airdrops, or again, DEX borrowing, lending with runes. We've got grants program, just opened a new wave, so your building does not have to finish here at the hackathon. It's a pretty great program on top of the financial funding. We do have actually 3 million USD to give out, but we offer also technical support, go-to-market, and just generally we do care about our ecosystem. So yeah, if you like to learn more about it, maybe find us at the booth and we'll give you more details. I'd also like to invite you to join our ambassador program and be part of our community. All the info is on the site. The 3 tracks we have here, so any DeFi on rootstock, best runes, as I mentioned earlier, and best use of rootstock blockchain. Can be anything you like, from AI to real-world asset tokenization, DePIN, whatever takes your fancy. We also have a bounty for that. This is the hacking guide that might be handy, so that will have all the documentation, all the resources you might need, but you can also find us at the booth. We will be there to help you. That's pretty much it. Come do say hello. We do have a booth. Thank you so much for attending, and hopefully see you around. Contract went through. Here we go. 2 minutes ago, contract call. Thanks, guys. So rootstock gives you basically security of Bitcoin, so you're not held on Ethereum. You just use like Ethereum toolchain and the Solidity to build, but essentially building on Bitcoin with rootstock on measurement. I think we're running a bit, yeah. I can answer. I'll
Cool. Yeah, I'm good whenever. Awesome. Hey everybody, my name is Trevor. I work at Hyperlane. I'm the back-end team lead there, so kind of all this Rust infrastructure that powers a lot of the delivery of messages, that's what my team does. Today I'm going to be talking a little bit about just what Hyperlane is. I'll give like a brief overview of like the architecture, what we do, what problems we solve, and then chat a little bit about some recent work that I think is pretty exciting around using EigenLayer for economic security for messages between two different chains. So just to give some background on the motivation for Hyperlane, we are a modular and permissionless interoperability protocol. And what this allows you to do is just essentially send messages between two different chains. You can build applications on top of this messaging that like natively span multiple chains, whether it's EVM, Cosmos, Solana, pick your chain. Yeah, the motivation for this, I guess taking a step back and looking at some of the history, at the very, very beginning, we had a pretty homogeneous view or architecture of blockchains. It started with Bitcoin, then we had Ethereum. There was kind of this new wave of smart contract style L1s. There was no solid story for scaling that we have today, but a bunch of alt L1s were created that were EVM compatible. And this was still like a pretty homogeneous environment, but slowly getting more specialized. And then there's the app chain movement where you have these chains that maybe don't even have a VM. They're tapping into like consensus layer changes, protocol level changes to try to extract these new like novel protocol level features. You're seeing that with rollups today, and you're seeing all these different types of chains that each have their own little flavor of what they're trying to do best. And this posits a problem where if I'm just a normal user, now I kind of need to know what all of these different quirks are for all of these different chains. I need to have different tooling, different wallets. If I'm a developer, it's even worse. There's a reason why most people are just EVM developers. It's because it's easy to do and you can kind of bring it most places. But if you do anything like outside of that or want to go to other chains, that's where things get a little bit tricky. Even just managing token balances across all these different rollups, I have ETH in like 20 different places, total pain. And yeah, interoperability is an interesting one because a lot of the solutions for this rely really heavily on like consensus layer or protocol level details of these chains. So you can have amazing security between two chains by tapping into the specific features of the consensus algorithms of these chains. And you can spend a lot of time and money to build something like this, but it's not very transferable. So there's this kind of trade-off of spending time solving security problems when it comes to interoperability that tap into the specifics of chains. And that provides a tension with wanting to be in as many places as possible. So what we do is we noticed, hey, security between chains when it comes to interoperability is almost an unsolved problem. And today, developers want this. Today, users need this. And our solution was to decouple the transport layer and the application layer. So what this means is there is a single on-chain interface for sending messages from one chain to any other chain, whether it's from EVM to Solana, whatever you want. And the security for these messages is not baked into the interface that you use. So if I'm an application, I can continue sending messages through this single contract, we call it a mailbox, to whatever chain I want. And as new security options come out, I can update that. So applications can opt into what security they want without the protocol dictating what they need. So this provides, a consistent application interface for messages. If you want to develop an application today that's only on the EVM, but you have plans to go to other chains, you can do that really easily with Hyperlane. If you're excited about a ZK proof that's coming out, for Ethereum consensus, but it's not available today, you can build today, add it later. You can also do cool things like having the security scale with what the message content is. So let's say you're building a bridge, you might want cheaper security for a message that is only transferring $5, but more expensive security for one that's transferring $1 million. So you can kind of dictate the level of security you want depending on what exactly you're doing. And this kind of just leans into the general ethos of being maximally composable, developer first, and modular, in that like we have this single protocol that doesn't enshrine what applications want to do. yeah, this is kind of more on that. Like you can configure what security preferences you want. We have kind of these like little Legos of security modules, which is what we call them. Where as an application developer, all you really need to do is just configure some on-chain things, on-chain contracts that you can provide, or we provide, and you get kind of different flavors of security. So we have like a single interchain security module, which is a contract that defines this function that can verify proofs, whatever you want, for the validity of messages. And we provide like some little Legos of how to create those, which is nice. And modular interop is the one interface to message and secure them all. So meaning we've kind of made these like really specific design decisions, so that way we have this like single immutable protocol, and you can build all these cool things around it as crypto evolves. So more specifically, this is what the architecture kind of looks like. So on the origin chain, we have a sending contract. You would encode whatever message you want. So at its core, it's really just like bytes over the wire between these two different chains. And you can build these like abstractions, applications, bridges on top of it, whatever you want. This message gets put into a Merkle tree on chain, similar to how the ETH like original ETH 2.0 like deposit contract worked. And again, we don't really like require a specific model of security, but we have this commitment, which is the Merkle root, including all of these messages that you could have a ZK proof of. You could have people signing this, whatever you want. But the gist is, on the origin chain, messages go into this thing. A commitment that attests to all these messages is provided. You need some kind of proof to the validity of this commitment, and then this is provided onto the destination chain. And then ultimately, this is sent to the recipient. So we run this like off-chain infrastructure that will deliver these messages to the recipient. So from your perspective as an app developer or a user, you're just interacting with the origin chain. We handle the rest when it comes to delivering this message to the destination chain. Okay, so getting a little bit more into the weeds of the first thing I alluded to, of some exciting things we've been working on. You know, we're not prescriptive about the security model that people use, but it is still important to provide really solid security as the default mechanism. So today, the default security we have is closer to like a proof of authority set. And again, applications, they can opt into whatever they want, but we make it easy for people to run these validators that sign these messages. And if these validators all agree on the validity of a message, then a message is considered fine. But what gets even better, or the next iteration of this, is you want that proof of authority set to have something at stake. So if they commit fraud, if they say that a message occurred that didn't actually occur, something bad should happen to them. Without this, they can kind of commit fraud and they get a slap on the wrist, or like, you know, social slashing is what people often say, of like, you know, my reputation is on the line as running one of these things, but putting real money on the line is kind of more in the crypto ethos. And this is what the proof of stake bit here looks like. So these validators, they're signing these message commitments. Their signatures are used for the verification on the destination chain, and they have stake that's up for stake. Okay, so what does this actually look like? Like, how do we slash these validators? So one interesting thing is we have a really nice slashing condition on the origin chain. So I mentioned earlier, when you dispatch a message, it's put into this Merkle tree. And you can trustlessly verify if a validator has signed a message that was not included in this Merkle tree. So we have a deterministic 100% slashing condition on the origin chain. Like, the root of the whole problem is, how do you kind of prove this on other chains, and that's what interoperability is. But we have this very nice slashing condition, and we can have an observer be responsible for looking at the signatures of validators and provide to this proof of stake contract, hey, Alice just committed fraud, let's slash her stake. Some cool things happen when you compose this with EigenLayer. So if you're not familiar with EigenLayer, it allows the ETH that's being used already for validating Ethereum to also be used by other applications for security. And there's like a huge ecosystem around this. There are these things called AVSs, which I think stands for like actively validated Stakers, yes. And we recently released this. There's a whole LRT ecosystem of these like different versions of ETH that have these eigenlayer operators. But the general idea is on Ethereum, you have this ETH that's put up as stake. And again, in the model I just described, you would only be able to have like a deterministic slashing condition on Ethereum. So that means that only outbound messages from Ethereum will have really good security, but the other ones, things get a little bit iffy. You don't have like a 100% slashing condition. But an interesting observation is you have also Ethereum rollups, which have their native bridges. Rollups themselves are defined by their bridge. So if you have a rollup that is settling to Ethereum, they have this trustless bridge. And this means that you can have the proof of somebody committing fraud. Let's say you're sending a message from rollup A to rollup B. You'd be able to still have this stake live in Ethereum by letting me prove to, on rollup A, the slashing contract, hey, Alice committed fraud. Let's send this trustlessly down to Ethereum, that Alice committed fraud for her origin message from rollup A, and then slash Alice. So we kind of get the same level of like 100% deterministic, really good slashing conditions now from origin chains that are not just L1 Ethereum, but L2 Ethereum. So that's kind of it on the economic security part. We have some recent work that we've done there that I think is super exciting. I think there's like opportunity for you guys to kind of hack around this, which could be cool. Now I'll just talk briefly about some other kind of abstractions and things that we have like out of the box that could be cool to use as well. So warp routes are our play on token bridging. And again, we're not prescriptive about the security model for token bridging or any kind of usage of Hyperlane, and warp routes also lean into this. So we offer the ability for you to just deploy out of the box tokens that are bridged, whether it's NFTs, ERC20s, XERC20 as well. And you can specify what security you want for these chains, or these messages when bridging. So we have a UI that you can use. We have a bunch of tooling to let you deploy these yourselves. So if you're looking to maybe support another chain that's here, maybe build out some kind of like proof of concept of bridging for them, like this is a whole self-service thing that you guys can play around with. You can also, we have this like yield-bearing version of this, so you can have maybe like when I'm bridging my ETH, it gets locked into a contract. That contract is generating yields, and then that yield gets shared amongst all of the people who have bridged, which is pretty exciting as well. We also have interchain accounts and interchain queries. So these are two abstractions that are kind of borrowed from the Cosmos ecosystem, also known as ICAs and I guess ICQ. And what these do is, in the first case, interchain accounts, let's say I live on Ethereum, I have a balance on Ethereum, but I want to own assets on other chains. Maybe I have a Gnosis safe on Ethereum. I don't want like, signers to have balances on all these other chains, submit transactions themselves. You can have your origin chain sender control what's essentially a smart contract account on the destination chain. And you can even have this cross between like EVM and CosmWasm, which is pretty cool. Interchain queries, this is, let's say I'm on Ethereum, there's some kind of like important state that lives on Avalanche. I can use an interchain query to receive that information back on Ethereum. So this would be useful for like oracleized data, maybe like an identity provider that lives on a certain chain. You want to bring it onto another chain. Another thing worth mentioning for all of these things, like a big differentiator for us, is anybody can deploy Hyperlane onto whatever chain they want. Anybody can deploy these kind of contracts on whatever chain you want. So if you're even spinning up like a DevNet, running Anvil locally, you can do this really easily. We've recently made some steps to make this even easier with like a more friendly kind of CLI. So yeah, this kind of leaning into like one of our big things that we say. So our design is modular and it works really well with the modular stack. This is kind of the typical like, Celestia perspective on what comprises of a blockchain. And we posit that adding interoperability to the top of this is our biggest contribution. So come build the modular expansion with us. We have an office in New York, London, we're hiring. We have a bunch of bounties. Come by the booth if you haven't already. We have swag, QR codes, list of what the bounties are. I'm an engineer, and with other engineers here, we're willing to help. And I think I have like maybe a minute or two for some questions if you guys might have them. Any questions? I'll go with no. Well, cool. Come by the booth, and yeah, happy to chat. A demo for it? Yeah, so we have a bunch of documentation about it. I'd say like no guides, but well, we have a guide if you were an operator, but this is targeted for like, I don't know, the validator operators of the world who want to actually like run one of our validators and earn rewards. But yeah, come by the booth and we can chat more. Cool. Thank you very much, guys.
Yeah, can you hear me? One, two. Yeah. Hello, welcome. So I'm from Galadriel. I'm a developer and a founder in the company. We're building the L1 for AI, and our reasoning is that we started building on other chains and then run into problems that we couldn't solve and decided to build our own layer 1 for this one that's optimized for AI use cases. Yeah. Okay. Is it better? Not that much? Ah, yes. Yeah, I'm gonna briefly go over like what we're doing, and I would like to focus mainly on how to build it. I will show some code examples and do some live demo. Yeah, so what you can build on us is the some of these examples. It's also linked on our docs. So some of the AI gamings, economics, agent swarms, and trust and transparency for AI, so you can actually see on the chain what's going on, how is this logic working. We have shipped some of the examples as well, fully open source, what we have built. So first one is the obvious one, which is a like getting started one. On-chain ChatGPT, you can chat with it. You can see the front-end code, what's needed, the solidity contracts, and the script, how to call it out. We created an AI game as well, based on Vitalik, which is a fully dynamic game. So each game is fully unique. It's generated by LLM. So like, what's what's the environment in the game, what's the actions can happen. It's like a battle game, you have to fight. And also fully open source, so if you're building, you can see how it's built. Generative AI NFTs, the same thing, it's fully open source, you can check it out. And also AI agents, which is essentially one LLM is one smart contract, and it can interact with other smart contracts. Yeah, and this is explanation in here how it works in the first phase of our network. We call it Trusted Execution Enclave. So this is completely separate part of the CPU, essentially, on the computer that's isolated from the rest of the machine. So, and you can cryptographically attest this, that whatever is running inside, you can completely verify that it's running exactly as it should be. And here's the demo. You can try it out immediately. You need to have the MetaMask, so everything you do in here is a specific transaction on the blockchain. And there's a small image as well, how it works. So you have your smart contract. It's like any Solidity smart contract. All your existing tools work on EVM. And you're calling our Oracle contract, which then afterwards, after it's done computing, it answers back to your contract. And the Oracle itself is in the execution enclave, as I mentioned. And you can see also these attestations and how to verify. This is also open source on GitHub. So if you have more questions like how to verify this, it's up there. I will maybe jump into the quick start. Maybe the white screen is better. Before you can get started, so this is our quick start as well. I'm not doing anything secret. It's all up here as well. You need to get new wallet, preferably new wallet. You can use our existing wallet as well if you want. But you need to first get the DevNet tokens. So you have to log into our Discord and get it from there. You also have to set up a new RPC if you're using MetaMask, but it's also like linked on the website. And after we have this ready, we have the repository in GitHub, so you can see what's inside there. I have it already cloned in here. Well, maybe first look into the quick start contract, just to give you a brief understanding what it is. So it's Solidity contract, quick start. It's a constructor. As you saw from the previous image, you need to interact with our Oracle contract. So you need to have the address of this Oracle contract. You can set it up however you want, but this is just one way to do it. You also want to make sure that only the Oracle can call back your smart contract, because otherwise, like anyone can call it and inject rubbish inside or hack you. And how it starts, initialize the interaction. You call this function, whatever is your input. So this is like just a text. And this one calls our Oracle, so it works through the interface. And the message goes in here. So this is just one of the function calls. We support a couple of other ones as well. You can check it out from the docs. And if you call this out, then your transaction is done. It's an asynchronous operation. So the Oracle in the backend does its job, generates it, and then calls back your contract. It calls back this function, and then the response is saved to the contract. Of course, you can do anything that you want in here. You can have your if-else sentences.
Any like time constraints, like similar to the Oracle peak price here? Just to make sure, like,
so
the latest code. How can I make sure like that's the latest code?
So the question is how to make sure I got the latest call. Yeah. This is up to you to design, to be honest. So in here, as you can see, it's just last response. You probably maybe want to have like an array.
Which call I know, like which call I'm expecting here.
Yeah.
Similar to the peak price Oracle.
Yeah. So the question is like how to understand which callback was made. This is for the purpose of the demo. Just essentially have this one boolean. It's set or not. But in reality, you probably want to maybe introduce your own data structure, an array. You can set it as with an ID. As you can see, the first parameter is the run ID. So you can use this one to track like which is the call and which is the response. And you can of course have like more complicated data structures, maybe like nested classes and whatnot. Yep, perfect. I'll maybe quickly show how to run it as well. In this one as well, we have the .n. In the .n, I will show you what I have inside. So my private key, you can copy paste this, which you need to add in there, and the wait, it's the wrong .n, sorry. Yeah, this is the one. So the Oracle address, you need to understand what's the Oracle, and your private key. We have two different ones in here. One of them is for your actual own blockchain, but if you want to run the local blockchain, you want to use the different keys in there, it's just for this reason, but you can most likely just use the same ones. I have the .m setup. You need to, of course, install your dependencies and deploy quick start. It's just a simple script. Essentially, we're using the ethers.js. We're getting the Solidity smart contract code, putting in the Oracle address, and then just deploying it. Pretty straightforward if you have done this. Sorry, I already showed the. Yeah, I mean, this was my example I just showed. Yeah, all good. It's compiling the contract and doing the deployment. And yeah. It's working. Yeah. So you get your contract address, and I'm setting it in the terminal variable. And then you can call this out. So this quick start is image generation model, so using DALI in the background. And now I can call this contract out. It's asking for the input. So this is sent to this quick start contract as I showed, and this is calling out the Oracle contract. And now the Oracle in the enclave is seeing that someone is requesting a job to do. It does this compute in there, generates the image, and at the moment it's uploading this not to IPFS but to our cloud. But it conceptually doesn't really matter. It's just more convenient to get it up and running for the demo purposes. And now you can see that yeah, it generated an image. Hopefully there's apes as well. Yeah, a lot of apes this time. Yeah, I have 8 minutes. So this is the first like simple example. We also have the Explorer as well. Maybe I'll show it. It logged out that there was the transaction, and now you can see the transaction in here as well. And I mean, I think everyone has used some Explorer. You can put in your transaction or your wallet address or whatnot and go there, the contracts as well, and then you can see what's happening in here. 1 minute ago, called this function. Yeah, I think we have seen these ones before, but for our purposes, we want to make it possible to build more complicated agents. We'll maybe show the vector store support. So RAG is very common technique in the AI field, which is having a knowledge base for your AI. So if you have used ChatGPT, you're asking some details of outside world. It usually doesn't know. It only knows what's inside the model. So how you can improve this is to have a database essentially with different facts, for example, or you put a book, the whole book PDF inside of it. But this whole book you cannot send to the AI immediately, or like the LLM immediately. You probably need to find the correct place in the book to send to the LLM. And so this is what the retrieval augmented generation is. So it's a similarity-based search database. It's a bunch of vectors, bunch of numbers. But we have made it hopefully a bit more accessible. So on the Python side, you can put in your data. So I created, this is also in the repository as well. So we have these RAG tools. Created a simple data when I'm presenting, and I took the next one as well. So Celo is presenting. We need to make this upload this to IPFS so that the Oracle can access this. I have a simple script in here. It's unmodified. It's just the latest version of in our repository, and you can upload this to the IPFS, and then you get the IPFS CID back, and then you can put this while it's uploading. I will show you. This is the ChatGPT example in here. So it's a contract, and how this works is, the knowledge base CID goes inside as well, so it can forward this to the Oracle to be used. Similar stuff. So if you start the chat, so first it checks like if it has a knowledge base, and if it has, it's making the knowledge base query. It's again async operation, and after this finishes, it calls back the callback function that you got the knowledge base query back. So hopefully it found this first line of this text, returns this to you, and then after you got this back, you can make the actual call to the LLM. And once this is complete, you get the callback to this function. This is one-off example, but now imagine you can have in here as well another maybe knowledge base query or another LLM query, essentially like a for loop, right? Or you can call another smart contract out that does, maybe another piece of operations, couple of calls. Question is about can we do multi-chain? Not yet at the moment. Currently supported chains, so this is only this chain. It's at the moment isolated. We don't do the cross-chain integration at the moment, just only the EVM. But this is definitely on the roadmap. It's asked like, okay, for DeFi applications mainly, like how can I get some more liquidity from other chains to LLM stuff, put this back to the other chain, to the trades. Yeah, so added the knowledge base. I got back the CID. I think I need to just quickly modify the previous example to deploy. Now deploying this contract I just showed, the ChatGPT one with the knowledge base. And after this one is deployed, I can actually ask when is my presentation time and show up. Yeah, it's deployed now. So now what happens is what I described. It first gets the data from the knowledge base and puts this into the LLM call. And then hopefully it answers the right time. Yeah, 15, 20. I'm not sure why it's doubled. It should be just once. Yeah, that's what I wanted to show. Do you have any questions? I guess not. So that's it. We're at the booth. Yeah.
So actually, what about prices? What part is you? What do you expect in
So the question is, what do we expect and what are the prices? Yeah, we expect to see AI agents. This is what we were interested in. The prices, I'm actually not sure. I think you should visit our booth. Our product people are going to be there as well, and we can sync ideas and share like what we're interested. I think they listed a couple of ideas out as well, like what would be one of the examples. If you just want to build on us but don't have any idea, then we can suggest something as well. Yeah, thank you very much.
Okay, so hi, welcome to the Flare's workshop. So what is Flare? Flare is a blockchain for data. What does that mean? Well, it means that you got your ordinary blockchain that can do all these important, necessary security-related stuff. But what you also get is an additional data sources directly on chain. So it's not your everyday multi-sig pushing data on chain. It's a properly secured data when you know that the whole validator set is making sure that the data you get on chain is secure and exactly what you need. So what you can do with Flare, well, you built on an EVM chain. So EVM chain that has all the nice things you're used to building with, all the toolings, and you can do it with data. So we offer two different prices. The first one is 7K price for the best utilization of Flare's enshrined pricing oracles, together with layer 0 V2 or with any other cross-chain connectivity that we also offer. So use a price you can get every second on every block and do something with it, not just on one chain, but do it cross-chain. Use liquidity somewhere else. Use the tokens deployed somewhere else. Buy something somewhere else, use information for Bitcoin, and do this. And secondly, we also have a second track, which is the most innovative application using Flare's data protocols. So apart from just pricing oracles, we also offer additional data connectivity oracles when you can observe what's happening on other chains without any additional interaction from other chains. So you can observe non-smart chains. You can observe Bitcoin payment. You can observe XRP ledger payments. You can observe what's happening on Dogecoin. And in that case, you can also apply for that track. Okay, so what's specific with Flare? We offer native data acquisition protocols. So those are enshrined directly into the chain. What does that mean? Well, we have three different things you can work on this time. So the first one is the FTSO. This is Flare Time Series Oracle. So for probabilistic data, we offer price updates every block. So that means that we have 19 different price feeds, currently only crypto, when you can get a price update every block. And those price updates are directly published on chain. You don't have to query them, you don't have to request them, you don't have to pay anything for them. You just read them from a contract, and we'll see how easy it is to do that in the following few minutes in the workshop. And all this is operated by a staked network of validators. So you know that the prices are always correct and can't be manipulated by people that want to gamble your system when you have a perpetual DEX or when you have some future set up. And secondly, we have Flare State Connector and Data Connector, which allows you to connect to additional data sources. What does that mean? Well, that means that you can have a deterministic off-chain attestations. You can attest to data being presented on another blockchain. You can attest that Bitcoin transaction has happened. More specifically, you can attest that in a specific time range, Bitcoin transaction hasn't happened. So you can know that the payment that was supposed to be made for something wasn't made. You can know that if somebody is building a swap, when you have one swap on Bitcoin side and one swap on Sepolia or Ethereum side, you know that one person did not complete their leg of transaction. And again, this is enshrined directly into the protocol level. So you don't have to trust a multi-sig built on top of this. You know that this is secured by the same validators that are building the blocks. And thirdly, we've recently integrated with layer 0. So what that means that you get the whole mesh of all other EVM compatible networks directly on Flare chain and combining the first two oracles. So giving you immediate pricing data and giving you data about the state of other chains, about what's happening in the rest of the ecosystem. You can easily build a bunch of dApps that are integrating cross-chain, moving data around, getting to the best liquidity positions, getting to the best information sources, executing this on a smart chain, and then going whenever you want. All this properly secured directly on a validator level. Okay. So just a few things important for the hackathon. So Flare is an EVM layer 1 Oracle network. What does EVM layer 1 means? Well, you get all the nice things you're used to when building on Ethereum or on Polygon or any other chains. So we're proof of stake, you get the security, block time is very quick, so you know that you'll get a block in the next second or so, so you don't have to wait for a while, you don't have to wait for the transaction to happen, you can do things immediately. And combining this with fast pricing updates, you know that you can execute quick trades and you can be there on time. So you're not waiting neither for an old price, neither for stale state. The transaction fees are low due to the efficiency on the network level, and you can use pretty much any tooling you want. So we offered pre-prepared hard hat and foundry tool sets So you can start with a starter pack that has all the RPCs already configured, all the faucets that you would need, all the necessary block scout tools, so you can easily interact with the whole ecosystem without having to change anything. If you know Solidity and if you know some TypeScript or some Rust, it's easy to start, you don't have to change anything. And as an EVM chain, you get pretty much all the goodies that can exist on such chains. So ERC20 tokens natively supported. Web3 authentication directly available. So we have also, from the DeFi perspective, multiple NFT marketplaces, tooling, periphery support, all the SDKs you would need, and stuff like this. So it's easy to start. And again, a large DeFi, account abstraction support, stablecoins, you know it. This is Flare. So you have oracles, you have data directly on chain, it's quick, and you don't have to change your tooling. And now, let's take a look how exactly these things work. Okay, so if you want to build on this, the first bet would be you come to our booth, or you scan this QR code. We have a starter pack, which we're going to start building on from now, and we have a whole set of developer documentation specifically tailored to start building. So, okay, let's wait so that people sync. Okay, so we'll be starting from this starter pack. Why is starter pack useful? So we'll be starting from the starter pack. Why is it useful? Well, it's a simple hard hat project with all the necessary stuff already configured. So if you've seen the hard hat system at some point, we have all the necessary contracts set up, all the private keys you can just import from the environment file, and all the Ether scans are already in, so you don't have to configure anything. If you start running into any problems, hitting the RPC a bit too hard, just visit us at the booth. We'll give you API keys so you can just knock yourself out and do whatever you want with the RPCs. Okay, so we start with the starter pack that importantly already has the Flare's periphery contracts directly in. So all the interfaces you're going to see, everything you need, it's already in. It's type safe, it's made in Solidity, so you can easily call them, you don't have to hard code anything. So you can just easily start. Okay, and let's take a look at the first one. So it's the .flare.network. So this is the entry point for documentation, and the first one would be the FTSO v2. So that's the most important thing, the pricing oracle, getting prices quickly and efficiently on chain. And let's just, and what you want to see is the systems explorer. So for each FTSO, so we currently offer 19 different prices, and for each the FTSO, it's easy to see for each data source, it's easy to see what the prices are. So the prices are updated on a block level. We offer a bunch of nice visualizations when you can check how this is getting updated. So okay, here the shape is a bit jagged because of the issues with the amount of pixels. But in this way, you have a fast update every block, and you know that this is getting correctly processed by the data. Okay, so these are fast updates, and each of these feeds is associated with a specific feed ID. Although this thing here might look a bit scary, it's basically just a hex encoded BTC/USD. So that means that we can easily extend feeds to pretty much any feed you want. So you can combine feeds, you can add new feeds, you can add new feeds that are not necessarily dollar denominated, but can be stablecoin denominated. And we've seen in the past that stablecoins might depeg, so you want to know what exactly is the feed you're looking at. Okay, so that's the data we'll be observing, and let's just take a look at how this data looks directly from the contract. Okay, so this is a simple contract interacting with the FTSO v2. Is it big enough? Can you see it at the back? Okay, so there's a library which I've copied in here just so we can see it. In a real world use case, you would, or on a hackathon, you would just import it from the registry. So we don't want to deal with all the necessary bureaucracy. So what do? If you want to get a feed ID, you just supply a name, and we properly encode it to bytes, so you get this feed ID that we've seen in the beginning. And getting the feeds, well, you just have to query the correct contract. And how do you get the correct contract? Well, on chain, we always maintain a simple contract we deem an entry point to the whole Flare's ecosystem. So what you do, you first get to the Flare contract registry that is always at a fixed address on all the networks where Flare operates. So Flare is composed of testnet and of a mainnet, and we try to keep the addresses for both testnet and mainnets the same so that it's easily to port data between those two. Okay, you get the Flare contract registry, you get the fast updater contract by the address, and then you can work on. And what do you do? Well, since the data is available off-chain, you don't have to do any pre-calculations. You don't have to request it. You don't have to pay for it. The only thing you need to do is you just say FTSO v2 fetch current feeds. That's it. And you provide some feed indices. So each feed is associated with a specific index. So indices are hard-coded here. Flare has 0 index, Bitcoin has index 2, and Ethereum has index 9. But you don't want to query the feeds by indices. You want to query them by name. So how would you do that? Well, we also provide a configuration contract in the middle that just acts as a simple mapping between feed names that you would use encoded and feed IDs on the fast update contract. So how would you do this? Here is another piece of Solidity code when you can get feed values by name. And what do you do? Well, you just say, okay, I want to get this, I want to get some strings, so I'm just going to supply you XRP, Bitcoin, Dogecoin, whatever, and I want to get the pricing for each of those feeds. So what do I really get? I get the values, so I get the price of this specific asset at this specific point. I get the decimals, because the feeds can vary by quite a lot. We provide the feed value denominated in some decimals. So for Bitcoin, you get a bit less decimals. For more volatile tokens, you get a bit more decimals. And you get a timestamp. This is the latest update for this specific feed. Why do you need this? Because sometimes you might get a few feed updates in the same block, or you might get 2 blocks in the same timestamp. So it's not only important to know that you're in the correct block, it's important to also know that the feed was correctly updated. And since all the feeds are updated in batches every block, you also get a timestamp just to have some sort of a sanity check to know what it's doing. Okay. And then there's just a matter of a simple conversion. So we use the pre-provided library to convert the feed. So we take a look at the configuration file, get the feed ID, and use it here. And after that, we just fetch all of them and return them. And how do you use this on-chain or off-chain? Well, simply, you just create a simple hard hat script to deploy it. And let's just check it right now. We'll deploy this on constant 2 and also directly validate the smart contract so we can immediately interact with it. It's deployed here. And in a second, the contract's verified. Okay, let's open it. Okay, so we got the contract, and it's easy to then just get into the correct set, to get to the correct method and say, okay, I want to know Bitcoin price, and here it is. So, might not be very visible. Yeah, it got. And there it is. So, Bitcoin up to 2 decimals right now. So that's the important stuff. So you get it immediately as a view method, no checking needed. Okay, those are the fast updates. Important if you want to do something DeFi related. Know what the price is. Arbitrage an existing DEX. Know that if you have a perpetual futures, you want to know that the price is correct. If you see somebody providing liquidity, you can use the on-chain oracle to know if the liquidity is mercenary or not. Is it doing something good? Is the price being moved too much and you want to offset this? This is the baseline price oracle you can use. Okay, that's the first thing. So connecting to external world and getting the pricing data. And the second thing you can do on Flare is get data from external data sources. So you can get data from external chains and connect to them. Let me just open this one here. And to do this, we use Flare Data Connector. So what you do, you request an attestation about something that's happening somewhere else. And the easiest thing to check is just go to Sepolia, take an old block, take a random transaction, take an old block, pick a transaction, let's say this one, and say, okay, so we have a transaction, it's made quite a lot of events, and it did some contract call. Why is that useful? When you're observing external networks, you want to not just know that something has happened, you want to be pretty sure that you go deep and you can extract a lot of information. So what state connector does, data connector does, it allows you to see into this specific transaction and prove all this data on Flare. So this is just a nice Swagger UX. We also provide the same tooling as with the FTSO to just do this directly from the JavaScript. So what I'm saying here is, okay, go to EVM chain, go to Sepolia, and give me information about this transaction. So I get some additional response, which is, again, a bit small, but I get a bunch of information about this transaction that can be then proven on-chain. And what do I get? I get the block number, the timestamp, the source address, and I also get all the events that were emitted inside. So do I want to know if a specific Uniswap swap has been made? Yep, I can see this. Do I want to know if an ERC20 token was transferred? Yep, I can see this. Do I want to know if some liquidation was triggered because of some specific condition? Yep, I can see this. I can take this information and I can push it to Flare. And then on Flare, I have this information from other chains, information provided by layer 0, and then I can execute pretty much anything. Okay, so that's on EVM, but apart from the smart chains, when you can easily do this using existing bridges, we can also do this for Bitcoin. Bitcoin, Dogecoin, and XRP Ledger, and we can do this in the same way. So we take a transaction, and we can check that this specific transaction has had some effect, has created something, has transferred value, and had a specific transaction identifier identified by the operator and opcode. So what does that mean? That means that you can have a simple payment method when you can say, okay, pay me on Bitcoin, and State Connector can safely transfer this directly to Flare, and then it's again up to you. Use this information, do something with it. And that's the connectivity part. So you have a smart chain with EVM support. You have real-time pricing with a lot of assets. You have real-time data about what's happening on other chains. And as a bonus, you have layer 0 integrating Flare with all the other EVM chains that are compatible. So what that gives you secure data, that gives you connectivity to other chains, and that gives you the ability to use this hackathon to build something amazing with price data sources, combine this with other chains, and get some bounties not just from us, but also from layer 0, and also from pretty much any other network that is participating. So that's it. That's Flare. So getting your data in a secure manner, knowing that it's there, and acting upon it directly and immediately. Okay, that's it. Any questions? If you want to find us, we're on the booth on the far side. Come to us and see us.
Hi everyone. My name is Anton Bukov. I'm co-founder of 1inch, and I'm gonna tell you today about some interesting algorithms in DeFi, which I find the most interesting ones, and I'll tell you why. So we can see that DeFi computations are very limited. And this is happening for many years, and we all wait till blockchain adoption, and we believe that blockchain computations will scale eventually with sharding or anything else. But I'm in this industry for like 7 years or something, developing protocols, and I don't see that computational capacity is actually increasing. So yeah, we should work with what we already have, and I believe we still can have highly scalable or infinite scalable protocols in current state of DeFi and blockchains. So yeah, that's what I'm going to show you, some algorithms in their projects, and I will describe how exactly they work. And yeah, this is not only for developers, hackers, builders. This is also for understanding how different are those projects from each other and how they are different from other projects which do not use, for example, such cool scalable algorithms. So first of all, here you can see there is a classification. You can see it's like distributing value. It's about value redistribution among multiple participants. So it can happen in the same value or in the another value, different asset. It could happen instant or it could happen gradually over time, each second, each block, something like that. And it could depend on direction. It could be dispensing value or collecting value from big number of users. So here I have examples of some projects which already have those algorithms, and I classified them. So yeah, let's start from the beginning. You can see that same asset, instant dispensing, you can find AMM's logos. So what does it mean? Whenever someone uses AMM pool for swap fee is being accounted in being redistributed among infinite amount of liquidity providers. It does not matter if it's like 10 providers or 1,000 or million or even billion providers. Computational cost for this is the same because this algorithm have constant complexity. So next one in this table is same asset gradual dispensing. Let's start with this slide. So how money markets usually work? So those who borrowed liquidity, their debt is increasing every second or every block. It's being accounted like that. And they, like, you can say they're paying some annual yield. For lenders, it looks the opposite. Lenders get value, also accounted every second or every block depending on the implementation, but it's happening gradually. And the thing how it works inside, you could think that it's like collecting values and dispensing values here, but actually implementation of money market is different. They're using same algorithm in both sides. They're dispensing debt and dispensing collateral. So that's why they all, money markets are listed there in gradual. And projects like Maker, which are, I mean, they have similar algorithms and apply them similarly. So yeah, one more corner here is same asset instant collection. So there is a joke about rug pull. It happens instantly and collecting money from every participant. But also protocols, here is Opium logo, but there could be much more many projects which are actually like insurance protocols or options or other derivatives protocols. So whenever settlements happens, they're collecting funds from pool of participants. That's what I meant. And you can see that the different asset is not really popular among different projects, but I'm not sure that I have all DeFi projects here. For sure, I can't be aware of every project, but it's for the most popular. So if you have projects which are not here but like should be here or here, let me know. I will add them for the next time I will have similar presentation. So yeah, different asset gradual dispensing is something what we called farming, and it was initially used in synthetics protocol, and now it's being used among many protocols. Moreover, this primitive of dispensing different assets gradually could be used inside of many other protocols. So let me check what is the next slide. Yeah, and I forgot about this interesting use case. Right here you can see same asset gradual collection. I found only one project which is doing that. It's called Papaya, and it's infinite scaling money streams. How does it work? So you could set up streams which are actually constant streams, like how many assets are being transferred in 1 second, in 1 minute, in a week. It's being constant. So you can open a limited amount of outgoing streams, but for sure you can have infinite amount of incoming streams. So this protocol found a way to have settlement without enumeration of incoming streams. So it does not matter if you have 1,000 incoming streams or 1 million or even 1 billion of streams. You can get money from all those streams within one short transaction. How does it work? This protocol stores total speeds of incoming and outgoing streams for every account. Whenever someone's open new stream or close stream or change stream, these numbers are being recalculated for involved participants, and then you can count your next balance based on your previous balance, how much time passed in this moment, and your total speed. So sounds basic, but that's what allows you to have infinite scaling money streams actually. If we will see Netflix or YouTube or Twitter or OnlyFans or Patreon or anything else on blockchain, they should use accounting like that. So they will be able to charge millions or billions of streams with constant complexity. Gas cost will be the same for any amount of subscriptions. So yeah, one more point here is that whenever you see something is happening instantly inside blockchain, it's also, there is a room for manipulation here, and by default, those protocols, they are vulnerable to front-running and sandwich attacks. For example, whenever someone sees that huge swap is coming to AMM and huge commission will be earned by liquidity providers, there is a possibility to inject your liquidity right before this swap to get significant share of those fees and then remove your liquidity. That's what's happening. JIT liquidity, just-in-time liquidity. So on this slide you could see, for example, your liquidity provider with 3 millions of 3 different assets, DAI, USDT, and USDC, and there are 3 different pools. It's like Uniswap version 2 or maybe Curve or anything similar. So whenever you see huge swap coming to one of those pools, you could inject your liquidity. You could inject 2 millions out of your 3 millions. So that's how you can simulate 6 millions of liquidity, but you only have 3. If you would use more assets and involve much more pools, your coefficient will be much higher. Here is like virtually doubling your liquidity amount. But for sure, you will spend some money on fees for making those transactions. So it's not passive participation in AMM. It's more active participation, but it have own benefits. And on some networks where those transactions are like super cheap, it's more than feasible. And yeah, those projects which do this instantly, they have possibility to protect from this for sure. This can be done in 2 steps. For example, projects in same asset instant collection, such as insurance protocol, derivatives protocol, they lock user funds, and whenever settlement is happening, they charge users. So it's not possible to run away before settlement. Yeah, but some things like AMMs are still vulnerable, and yeah. But for example, for Uniswap, you can do Uniswap v4 hook. For those who provide liquidity, you can make it as a two-step action. First step to commit your deposit, and then you have to wait a few minutes, and then you can deposit, something like that. I mean, you could have some algorithmic protection from this if you consider this is something you want to solve. And that's it. Any questions? Easy, yeah? That's why I'm talking about it, because it's easy to understand that some protocols already utilize algorithms with constant complexity. And that's actually a huge benefit for them, because they are already ready for mass adoption, because they're ready for millions or billions of users, because each of these users will make transactions only when they need to do like real actions, when you need to borrow or lend, or you need provide liquidity, or you need swap, and you don't need any extra transactions for accounting. You don't need to collect funds, for example, from millions of subscribers, because it will be nightmare. You will I don't know if any blockchain can allow this. Like if Netflix gonna have subscriptions on blockchain, I don't believe that they're gonna do hundreds of millions transactions every month. We don't have such blockchains yet, and I don't believe we will have such blockchains in 10 years. And yeah, we have questions.
Yeah, so specifically to Uniswap hooks, you said that that could be one of the problems to solve in potential. I think they've advertised it as one of the bounties where you hook to, and then just like I got an idea that you said before the liquidity provider is actually committing, you can put something in between, but I'm not exactly sure which logic would stay between there.
Yeah, guys asked me to repeat questions before answering them. So yeah, in short, you asked about this slide where I told about instant actions, instant distributions of values. And you asked about Uniswap v4 hook, that you heard that there is a bounty for something similar to this. Yeah, I think it's possible to make protection from just-in-time liquidity providing. And you can make it, the only way you can protect from this is making it two-step, but yeah, it's not that simple. If you would make it simple to step, like commit that you will deposit and then deposit, people will commit and then wait till something is happening and then they will deposit. But yeah, you could came up to something not very, it will be not very difficult, but I think you can came up to something what would work fine for this. Yes?
You talked about algorithms in terms of computational complexity.
Yeah.
What about memory space complexity? Do you think it can change the picture that it will be not actually scalable in the ways that memory is not free, even if we are doing sharding? What is your position about the memory space?
Okay, I'll repeat your question because I was asked to do this. So, yeah, I talked about computational complexity, but for sure there are other complexities for other parameters of those algorithms, as memory, consuming notation, and other things. Yeah, I think this is also important, but I never met protocols which have which store much more data than actions that are happening. I mean, like for one storage slot, for few storage slots, for like some actions, for some users, you do not like explode on data which you need to store in smart contracts, because it's actually the most expensive thing in blockchains. It's like it costs insanely more comparing to computations. Like for like numbers, adding numbers is like 2 or 3 gas, while storing new slot is 20,000 of gas. Updating existing slot is 5,000. So numbers are really wild for storage. Yeah, one more thing regarding complexities is that whenever you consider those complexities for your algorithms, uh, anything which is like linear to number of participants or something like that is very dangerous, because when you write smart contracts you should always think about computational complexities, because your computation is actually limited by the block size. If you need to perform like loop in your code over participants or something like that, it will stuck whenever you have few thousand of users, because this loop will consume more than 30 millions of gas in Ethereum mainnet. And yeah, I mean, the size of block is mostly comparable for the most of blockchains. So I don't believe we have any blockchains which have like billions of gas or something. But yeah, this is something what auditors will tell you if they will see you have a loop over something which can grow dramatically, which is not limited in terms of its size. Yeah, auditors will usually let you know that this would not work, and you can split this by having this loop in multiple transactions. But I would suggest you to reconsider algorithms you use to don't have those loops at all. Yeah, that's probably one of the reasons why this farming smart contract became so popular in 2020, because yeah, any amount of participants can be participating in this farming, and they can all join, get out at any point of time, and values will be distributed among participants in a fair way, and all those methods to join, get out, claim, they will all cost the same cost. Doesn't matter how many participants are participating. Okay, you asked about synchronous and non-atomic blockchains, which are probably sharded or something like that. And you asked how it will be affected, those ideas of scaling and computational complexity. I think it will be the same. I mean, making things asynchronous or non-atomic will not make it easier for you. It will be it will actually cost more, because it will be like a separate transactions, not like an actions inside one transaction. So yeah, hopefully you have to consider your algorithms, how it works on a different level. So yeah, this presentation is also about how people should build new protocols, think how they should consider new algorithms which are being used inside their protocols. And yeah, one more point is for people who are trying to understand how different projects correlate with each other, which one is better for this, which one is more suitable for this, because yeah, we can see in DeFi the huge variety of different protocols, but they all have different implementations, and they are being optimized for a little bit different things. Yes? Could you repeat? Yeah. Potentially yes, because when we are talking about declarative programming languages, I always start thinking about SQL, because that's one of the most popular ones. And the idea behind declarative languages, I think, so it was to make some optimizations which is hard to achieve with imperative language. For example, with SQL, query, you use indexes to boost complexity of your query, but you are not aware of those indexes actually. You do not use them implicitly, explicitly, you use them implicitly, and potentially some things could be integrated. I mean, we could see some declarative programming language for smart contracts which incorporates some ideas of indexing to achieve something. I think it's probably possible, yeah, something like that. Yeah, the difference between imperative and declarative thing is in imperative you tell what exactly is happening in your code. In declarative things you it's like intents, you ask for what you want to get, what you want to achieve, and actual things which are happening, they're happening under the hood, probably under the compiler or something. It depends on the implementation. Thank you for the question. Thank you, guys.
Hi everyone, welcome to the Chronicle workshop. I hope you enjoyed the small break we had before. Today we will talk about scalable, decentralized, and cost-efficient oracles. Before that, I want you to picture the following scenario. Imagine you're a craftsman and you want to build a boat. You want to build the most amazing boat out there, and you're spending months and months crafting your boat. Finally, after all this hard work, you're ready to test out your boat. But you soon realize that there is no water close to you. You cannot test your boat. Your boat is pretty much useless. When it comes to decentralized applications that use data from the real world, we have pretty much the same scenario if we cannot provide this data to those decentralized applications. Use cases such as stable coins, decentralized exchanges, decentralized insurance, and many more other need this data in order to function properly. And here is where Oracle comes into play. Oracles are the bridge that allows the smart contracts from different decentralized applications to access real-world data. A few words about myself. My name is Bianca Buza. I'm recently joined the Chronicle team as lead DevRel. You can see my socials out there. You can also find me at the booth in front throughout the weekend, so I'm more than happy to support you with your projects. On today's agenda, we already saw the problem we are trying to solve. We want to see how we can bring this real-world data onto the blockchain. Now we're going to look why Chronicle specifically, and then we're going to have a short application. We're going to see how we can get the ETHUSD price feed on chain, and then we're going to build small dApps. We're going to have a token vendor, a smart contract, where basically you can pay ETH, and in exchange you're going to get a specific token, a token that we built before. Now, a few words about Chronicle. We are the Oracle that has been powering Maker since 2017. Last year in autumn, we spun out of Maker under the branding of Chronicle, and now we are open to the community, so come build with us. In terms of TVS, or total value secured, we currently secure over 6 billion of assets. Now, Chronicle Oracle Scribe, it's an extremely gas-efficient oracle using aggregated Schnorr signatures. Schnorr signatures have existed for a while. They were starting in 1991. They even are integrated into Bitcoin. However, this is the first time when Schnorr signatures are used in the context of Web3 oracles. Now, what sets us apart is that Chronicle offers decentralized, verifiable, and scalable oracles. And we're going to take this one by one and see exactly what I mean by this. First up, decentralized feeds. Feeds are also called validators, or as you can see, our validators are reputable players in the space, which means that they have a stake with their own reputation to make sure that the data they provide is accurate. Chronicle oracles are also verifiable. We have end-to-end verifiable data, and let me show you a brief demo of what I mean by that. So here is our website, chroniclelabs.org, and you can go to launch dashboard. And let's say, for example, I'm going to take the ETHUSD. You can select on the timeline a specific date you're interested in. I'm just going to take a random one. And you can see in here the different validators that I was talking about. For each of these validators, let's say DeFi Saver, I can see, one second, because I pressed the wrong thingy. Okay. Yeah, you can see in here, this is the right page. You can see in here all the different validators. And for each of these validators, you can see the actual data sources. So let's say I'm taking the Gitcoin validator, you can see all the data sources that have been used, and as you can observe, it's a mix of on-chain and off-chain data sources with very good liquidity. Another cool stuff you can do, you can verify cryptographically in your browser that the data hasn't been manipulated. So if I go here at verify, I can see that the signature is the same. However, if I modify even slightly, let's say I delete a 0 over here, we're going to see that the signatures do not match anymore. Okay, back to my presentation. In terms of scalability, because of the optimistic Schnorr signature that I was mentioning before, we are able to achieve gas cost of over 60% on L1s and 68 on L2s. And this is pretty awesome because it allows for the first time when it comes to Web3 oracles to decouple gas cost from the number of validators. As you might know, oracles are expensive. So if you are an oracle provider, you pretty much have two choices up until now. Either you increase your prices, which makes you less competitive in the ecosystem, or the alternative, you reduce the number of validators or the number of updates, which results in stale data and potential threats on security and decentralization. So that's why it's really important to be able to make those gas reduction actually within the protocol, such that you can still have this rich ecosystem of validators and actual decentralization. Now, why we're here, it's a hackathon. We're offering 10K in bounties spread across 3 tracks. The first one is the DeFi track. Here, pretty much any sort of DeFi integration qualifies. So if you want to integrate our Chronicle oracles for use cases such as borrowing and lending the apps, decentralized exchanges, liquidity mining, prediction markets, stable coins, etc. Next track is the innovation track. Here, we're looking for innovative projects, and the innovation can stem either from the utility of the project or the idea itself. And please feel free here to scan the QR code. If you scan that QR code, I'm going to wait a moment for people to get a chance. I'm going to walk you through the page that will pop up when you scan that QR code. We got it? Okay, one more moment. So when you scan that QR code, it's going to take you to this bounty page. You can see here for each of the bounties, you can see the overview of the bounties with all the details, both for the submission, both some ideas for the projects. You can see here the GitHub repository that we're going to work on today. Some more information of how to use the Chronicle oracles, resources. Very important here for resources, we have a Scaffold Oracle Reader built on Scaffold ETH2. So those of you familiar with Austin Griffith's Scaffold ETH2, we are using that to leverage for our oracle. And very important here, you have the different addresses for our oracles on different networks. So you can check out the different networks. Some of these chains are also offering bounties, so maybe something to consider. And finally, how to get help. All right, back to the presentation. Yeah, finally, the last track, and probably my favorite because it's something I think innovative that I don't think I've seen before at ETHGlobal. It's a small education track, so for those of you that, I see here an issue. For those of you that might not have enough time to build a fully fledged project but still want to contribute and to ship something, there is a small pool prize. It's $600 USD spread across 2 tracks. I still know that the numbers are a bit messed up. But yeah, if you want to build a tutorial with Chronicle oracles, this is your track to go. Now, how do I use Chronicle oracles? First step is to actually get access. So our oracles are read protected, which means that you need to be authorized in order to read from them. The authorization process is called a kiss. It's very whimsical, I know. And the good news is that on testnet, you can self-kiss. You can authorize yourself. After you authorize yourself, you are good to go. You can start using the data to power your DApp. One thing to mention here, very important, is that you need to get authorized for each oracle that you want to use. So if, let's say, you want to use ETHUSD and ETHBTC, you will need to do the authorization for each of these two. Okay, and now finally the fun part. Here is the GitHub repo that we will work with today for our project. Feel free to scan it. I'll work a moment. I'll wait a moment for people to scan it. You got it? Nice. So first step, we're going to create our own token. I was using here the ERC20 token, and I was using the Open Zeppelin access control in order to manage roles. We have two roles, the default admin role in order to create roles, and then the minter roles in order to enable minting. So the address who has the minter role can mint tokens. Then in terms of the minting functionality itself, it restricts the token minting to accounts with the minter role. And yeah, it's pretty much the classical ERC20, nothing fancy here. I put the name of the token, the ticker. Feel free to choose to customize it for yours if you follow along. And I think we're good to go to the token vendor. So the token vendor basically will be the smart contracts where we're going to send our ETH, and in exchange, we'll get this token that we just created. So for the token vendor, we're going to start by creating these four variables over here. The first one is the Chronicle. This is the price feed. Is of type iChronicle. This is the interface for Chronicle oracles. Then we have the self-kisser. This is of type iSelf-kisser. This is the interface that manages authorization for the different oracles. And then we have minter and owner. Then in the constructor, we're going to deal with the different instantiations. First one is the minter. We're going to pass the address of our token that we just created, the ERC20 token. I put here some comments. You will see that this is hard-coded for Sepolia network. However, if you're using a different network, you can just take the address from here. You can just find the address from here corresponding to the network that you're using. So yeah, here we initialize the self-kisser, and then, oops. And then in terms of the Chronicle, we pass the address of the ETHUSD. We're going to use, for this example, ETHUSD, and then we're going to self-kiss ourselves, as I was mentioning earlier, in order to be able to read from this oracle. Next step is the read function itself. We're going to read from this Chronicle that we did in the previous step, and then we have the token amount function. In the token amount function, we basically calculate the price, keeping in mind that we deal with 18 decimal places precision. If you used other oracles in the past, maybe you've seen that they have like different decimal places. In our case, it's 18 decimal places for all our oracles. Also, something important to keep in mind here, We're handling everything in integer math, so Solidity doesn't have decimals, so it's important to, for example, do stuff like multiplication before division in order to maintain precision. Finally, we have the receive function. This allows us to basically send ETH and in exchange get our token, which is getting minter. We only have a modifier, only owner, to allow only the owner, and then the withdraw function at the end, we want, after we collect all this ether, we want to be able to withdraw it. This is it in terms of the workshop. I'm gonna show you a demo of this token vendor example. This is again the QR code, but I think you already scan it. So I'm gonna go and do the demo. I have here already the two contracts deployed, the ERC20 token and the token vendor. So the idea is now that I'm gonna send some ETH from my EOA, my externally owned account, to this token vendor address, and in exchange, I should get the token that I created. So let's see that in action. Let's send, let's say 0.1 Sepolia ETH. And after it gets minted, we should be able to see it on EtherScan Sepolia. Okay, it's confirmed. Let's view it on EtherScan Sepolia. So you can see that I received some Bianca token. If you remember, in the ERC20, I put it Bianca token, the name of my ERC20, 34 seconds ago. Yeah, it's a pretty easy example, yet powerful, to kind of demonstrate you the different functionality, how you can read from the Oracle, and how you can then integrate this into your DApp for the hackathon. Okay, I'm gonna put this. Are there any questions? Sorry, a bit louder, please.
Yeah, at some point you did it, you said at the end, can you show again the proof? Here the times 18 at the end, why you don't do it before?
Yes, so as I was saying, because we don't have decimals on Solidity, so we need to deal with integer math, it's called in Solidity. And if you're doing first the multiplication, it allows you to maintain precision when you're doing the division. So usually in real life math, it doesn't really matter if you're doing multiplication or division, but here, in order to maintain the precision of the decimals, it actually has an influence. It's 10 to the power of 18. It's 10 to the power of 18, yeah, no worries. Any more questions? All right.
All right. Hello, everyone. I'm Ian. I do DevRel and partnerships at Tools for Humanity, supporting the WorldCoin ecosystem. And I am going to talk about global proof of personhood, how you use World ID. So what I will go over in this workshop, I'll go over what World ID is, why WorldCoin created it, what you can do with it, and most importantly, how to integrate World ID into your project. Then I've also got a couple extra special notes at the end that are unique just to this event. So the big question that World ID answers is, how do you know who or what is a real and unique person, right? You might use CAPTCHAs online to prove that you're not a bot. AI is getting really good at solving CAPTCHAs, right? And when AI gets so good that CAPTCHAs aren't really that useful anymore, most places will then default to have you upload a photo of your passport or your driver's license or some other ID. And just a few weeks ago, the ID verification provider for Uber and Lyft got hacked, and photos of people's IDs got released and lots of personal information. So that's not a great solution either, right? So with World ID, you can think of it as this like passport, right, to prove you're a real human online, totally anonymously. We've built World ID to be private, inclusive, and robust, right? So for privacy, we want to know as little about you as possible, just that you're actually a real human. We want to make sure that as many real humans as possible get to use World ID, and we want to make sure that it actually does what it says it does, that with World ID, you know this is one real person. So when it comes to this, we looked at a lot of different approaches of how we can help solve this problem, right? Email or phone don't really work well. Super easy to get extra phone numbers, super easy to get extra emails. When it comes to doing KYC of official government IDs, while it does work fairly well for knowing, okay, yes, this is a real human, is verified by some government, the problem is that less than half of the global population has a digitally verifiable government ID. Web of Trust systems are a little more Web3 native, also can work fairly well, but they're not quite as scalable as we need them to be, right? In a Web of Trust system where you start with maybe 100 sort of pre-verified people, right? You might know them personally, or they might be well-known figures in the space. That can work well for a moderate scale, but when you scale up to all of humanity, you have to be so many sort of hops away from that initial core set. The more hops away you are, the less trusted you are inherently. And that leaves us with biometrics as really the next and only way to verify humanness that solves our needs. And when it comes to biometrics, there are lots of different biometric factors you can look at, right? Fingerprints, face scans, palm scans, those are ones that we're all pretty familiar with. But Face ID and Touch ID on iPhones can only distinguish up to about 1 in 30 million people. And those odds are great for authentication, right? I live in the US. The odds that the person who steals my phone is one of about 13 or 14 in the entire country that could unlock it with Face ID, I'm totally comfortable with those odds. That's way better than just them randomly guessing a 6-digit passcode. But we're trying to ensure that you're unique at the scale of billions, and 1 in 30 million is not going to get us there. We also looked at one of the most data-heavy pieces of biometric information, DNA, but that is impossible to do in a private way. We can't claim to not know anything about who you are if we're using DNA. And it's also really expensive to work with and invasive, and generally something we wanted to stay away from. So we settled on iris biometrics, right? That colored part of your eye around the pupil. It's got lots of entropy, so it can be used for distinguishing that you're unique at the scale of all of humanity. But it's also something that's visible. It doesn't require any sort of invasive thing, right? It's just a photo. If you don't want to have that photo taken, you can close your eyes. It inherently requires like consent and attention, whereas a face scan is something that someone could do like while you're walking down the sidewalk going past them. So that's why we settled on iris biometrics. And then when we looked at what we use to work with those biometrics, phone sensors simply don't have enough detail, right? A photo of your iris is not going to actually have a high enough resolution to get the iris code that we use to distinguish that you're unique at all of humanity.
We also looked at off-the-shelf hardware, if you've heard of Clear at the airports to like fast-track your way through security. We looked at hardware just like that, but that off-the-shelf hardware is very expensive, it's very heavy, it's meant to be at a fixed location, it's not portable, and it comes with a lot of trust assumptions about it, right? None of that off-the-shelf hardware is open source. So we had to settle on building custom hardware, and that was a pretty long train to get to being a hardware company, which we never wanted to do in the first place, but we did. And this is the hardware we built. This is the WorldCoin orb. The orb has been in development since early 2020, gone through lots of different revisions, making it faster, more secure, more affordable for us to build. And the orb makes sure that you're a real human. It has, I believe, over a dozen AI models running on the orb to check and make sure that you're not a cat, not a dog, not someone holding up a photo of a human, not a mannequin head, right? Making sure you're not wearing colored contact lenses to try and trick it into thinking your iris is different than it actually is. So, and then it takes a photo of each of your irises, and on the orb it calculates the iris code, a digital representation of the pattern of your iris. The only thing we use that iris code for is making sure that you don't get to sign up twice. The iris codes are stored in an SMPC setup, so there's no one entity that has your whole iris code. Right? We are actually like pushing the boundaries of how MPC is being used in production. And once we've verified that your iris code as generated by the orb is unique, then we verify your world ID. Your world ID is a self-custodial key pair stored on your mobile phone, and verifying your world ID means that the public key goes into a Merkle tree on chain, so that when you use your world ID to prove to some application that yes, you're a real human, only signing up or doing this specific action once, you're generating a zero-knowledge proof, proving that you control the private key to one of those public keys in that Merkle tree. We've designed World ID to be privacy first, decentralized, and open source, and the orb overall, right? So with the orb specifically, 95% of the hardware is open source. The only things that aren't open source are the security board, which handles like secure signing operations, tamper resistance, etc. Understandable why that wouldn't be open source. And then the majority of the orb software is also now open source, and we are gradually open sourcing more and more modules as we have them audited and ensure that they're safe to put out into the world. Because we want to make sure that the tech we're building is structured in such a way that it's difficult to use for any sort of nefarious purposes people might want to do. World ID has lots of different use cases that it's suitable for, right? World ID is built on Semaphore, a protocol built by PSE, funded by the Ethereum Foundation. And one of the core use cases there was around voting, right? You want to prove that you're part of a set and that you're casting a certain vote without revealing who's casting that vote. Social media obviously makes sense. We've all seen all the bots on Twitter and how paying $5 a month for a blue check mark doesn't stop bots from paying $5 a month for a blue check mark. And customer incentives are one that I find particularly interesting. Netflix used to have a free 2-week trial when you signed up with a new email, and people spun up a bunch of new emails and never ended up paying. Netflix obviously didn't like that, so they stopped their free trials. But if they were to use something like World ID, they could offer you a 2-week free trial or a 1-month free trial, and they know very strongly that you're only going to be able to get that free trial once, right? It doesn't matter what email you use. If you try to verify with the same World ID to claim that free trial again, they'll know that you've already claimed it. We've designed World ID to be super easy to integrate, using it either on the web, on mobile, or on chain. There's 2 main ways to integrate World ID: sign in with World ID and incognito actions. So we'll start with sign in with World ID. With sign in with World ID, you can use auth0, next.js, use our OIDC well-known file with some other library. You can custom implement your OIDC flows, on and on and on. But we'll focus on next.js. If you want to use sign in with World ID and next.js, this one single provider configuration is all you have to add to your configuration of Nextauth. And then you have implemented sign in with World ID, right? And we have a template repository that already has this built out, right? You don't need to try and snap a photo and type all of this into your code editor. But it's pretty simple, right? We are instructing Nextauth to use our well-known file that includes a lot of configuration of what endpoints to use, things like that. You'll put in the client ID and client secret that you'll get from the WorldCoin developer portal. And then in the profile, we include the ID, which is the nullifier hash, your unique identifier from WorldID for the specific website you're logging into. And then the credential type or verification level. Is this user orb verified, or are they just device verified, right? The device verification allows you to install WorldApp on your phone. WorldApp checks to make sure it's running on a real phone, not a virtual machine, and that only has one WorldID associated with it. So it's a much weaker Sybil resistance mechanism, but still a valuable one, because you'd have to spend at least $50 or so per phone to get another device verified WorldID. So that especially works well for signing with WorldID when you don't want to require that a user logging into your application has to visit the orb first, for example. Then we can also talk about incognito actions. Incognito actions are sort of the native way to use WorldID. With incognito actions, your application gets to know that your user is a unique human, doing an action only once, or however many times you want. You can make it 2 times or 3 times or 10 times or even unlimited times. You have that flexibility. And optionally, with a tamper-proof message that we call the signal. Right? So I'd mentioned that Semaphore, the protocol on which WorldID is based, had voting in mind as one of the key use cases. So this signal is where you would put the information of who you're voting for example. Right? It's a piece of information that's an input to generating that zero-knowledge proof, as well as verifying that zero-knowledge proof. And if it doesn't match exactly between both of those, the proof won't verify. And that's how you can make sure it hasn't been tampered with. Another place that you might use that signal is if you are, say, gating an airdrop behind WorldID. You might have that signal be the wallet address that should receive that airdrop. And then when you verify that proof in your smart contract on chain, you know that when they generated the proof, they wanted it to go to this address. So we'll just send it to that address rather than maybe the wallet that sent the transaction. And the flow with incognito actions is quite simple. The user will scan a QR code created by IDKit, our SDK, that's displayed in your application's front end, and that tells WorldApp running on their phone what application and action they're verifying for. The user will generate the zero-knowledge proof on their phone and return that zero-knowledge proof to your application's front end, and then your app will verify that zero-knowledge proof. And you can either do this off-chain or on-chain. Off-chain, it is an API point on our developer portal, whereas on-chain, it's directly in the smart contract. Right? And this is that zero-knowledge proof that your app will receive. The Merkle root says, this is the root of the Merkle tree that this proof was created against. The Merkle root on Ethereum mainnet for orb verified users is updated at least once an hour because we batch insertions from new orb signups. That nullifier hash is the unique identifier of that user for this specific action. Right? So for signing with WorldID, that will be anytime they sign into your app, this is that identifier. Or if you're using incognito actions, that nullifier hash can vary if you use multiple different actions within your application. Right? So if you have a vote once a week, you might use a different action for each vote. The proof is actually much longer than it looks here, and that is mathematically the zero-knowledge proof that's getting verified. And then the verification level tells you if this user is orb verified or just device verified. So let's see what using WorldID incognito actions actually looks like. So if I go to the WorldCoin docs in our try it out section, you can just experiment with WorldID here. So we'll go with incognito actions in the production environment. Since I have WorldApp installed on my phone, I will say I want a minimum verification level of device verification, And we have this action with this randomly generated string here, so I haven't performed this action before. So I'll click continue with WorldCoin. And this QR code pops up. So I can either scan this with the QR scanner built into World App or just with my phone's camera, and it will take me to the app. I see information about what application I'm verifying for, a description of the action, and I tap verify with World ID. So then on my phone, that zero knowledge proof is generated, sent back to the application. This application passes this proof to its backend, and its backend calls the WorldCoin developer portal to verify it off-chain, and we see that I successfully verified. So if I try to verify for this action again, I've generated another proof. It gets sent over to this application, and we can see that I've already verified for this action. Doesn't let me do it twice. So any integration of incognito actions starts with IDKit. With IDKit, right, and for this example, we're using React. IDKit is a single React widget. You give it the app ID and action as you configure them in the WorldCoin developer portal. OnSuccess and HandleVerify are two callback functions. HandleVerify gets called as soon as it receives the proof, but still shows that pending state. OnSuccess gets called after the proof has verified successfully. HandleVerify is optional because for on-chain use cases, right, you don't want to keep IDKit open, but have to have the user send a transaction. So for on-chain, you would typically just not define HandleVerify. OnSuccess would store that proof, and then you would have your user submit the transaction on-chain that would include that proof to verify. And then that last parameter, the verification level, you can set the minimum verification level you want for your user. That one's also optional. It defaults to orb verification. But if you're doing an app off-chain and you want to let the device verification be allowed, you can also specify the device verification. And then the child of the widget, in this case, is just the button that opens the widget. We do also have a vanilla JavaScript package that you can use, and we also have a cloud verification template using Next.js if you're interested in that. Right? So this proof response here is what gets passed into the HandleVerify and OnSuccess callbacks. Right? So after we see that green check, we're not done with it. I have seen lots of projects, both at hackathons and like production use cases, that get this proof back and think, great, the user's verified. But that is essentially, a piece of paper that says, yeah, I'm human, right? But you have to go check that the signature on that piece of paper is legit. So we have to verify the proof. I cannot make that clear enough. We have to verify the proof. And when it comes to verifying that proof, right, I've said we can do it off-chain and on-chain, and I'll start by describing how we do that off-chain. Right? So in your backend, this again is a Next.js example. We have our app ID and action from our environment variables. We get the proof object and the signal from the front end, right? So the signal, if that was specified, you can have it be whatever you'd like. We get that in the request body to our backend. We have this verify cloud proof helper function that will call our developer portal, pass in all the necessary information, and will return a success response or an error based on whether the proof verified or not. It'll explain why the proof wasn't verified. And then, if it was successful, you should return that successful response to your front end, or you should send a response to your front end explaining why it didn't succeed. But you would also typically want to actually do something now that the user's verified. And you should do that in your back end where the user can't manipulate state like they can in the front end. So that might be that you mark the user as verified in your database. It might be that you go ahead and send them a discount code on Shopify, for example. That's an integration that we've built. But verifying these proofs is super simple. It's a single API call, and we have a helper function that abstracts that away. For on-chain verification, it's a little more complex, but again, we have a template repository that already has a very basic smart contract written for you. So in the constructor of your contract, you need to input the app ID and action ID, again, as you got them from the developer portal. But world ID here is the address of the world ID router. Right? That is the smart contract that is a proxy that will always make sure that that contract address stays consistent. And that's where you call the verify proof function, submit the proof, and get to know if the user is actually verified with world ID or not. The external nullifier, as defined here, is actually a term from Semaphore. If you're familiar with it, you'd know that that's what they use to scope the uniqueness of an action. For us, we combine the app ID and the action ID to create that external nullifier. That is so you can have multiple actions within one application. So when the user scans that QR code, they'll see the same app, they'll see a different description for that action. But in Semaphore, like every time you change that action, it's something different, and the external nullifier is just the value that defines that. And then the function to verify and execute something here, right, that's left undefined. It takes in the signal, the root of the Merkle tree, the nullifier hash, and that proof object itself, a very long hexadecimal string that's really just used for all the math. And the first thing we do is that we check a mapping that we defined earlier that should have been in the slide for the constructor. We have a mapping of nullifier hashes where when we sort of use a nullifier hash, we mark it as used. So first thing we check is, have we seen this nullifier hash before? If we have, we know the user's already done this action, we're just going to revert because we don't want them doing it twice. You could also have that map to an integer and count how many times they've done it and limit them to doing it 5 times. But once we've checked that the user hasn't done this action before, then we call the verify proof function on that world ID router. So we pass in the root, the group ID, which on-chain currently is always 1 for the orb verified group. Device verification can't be verified on-chain at this time. Then we have the signal hashed a specific way to ensure that it's within the field of the curves used for the zero knowledge proof. The nullifier hash, that external nullifier we set in our constructor, and the proof. That verify proof function call will revert if the user is not verified or the signal is incorrect or for whatever reason it shouldn't. But if it does verify correctly, the program just continues. There's no value returned or anything like that. So the first thing you should do after that proof gets verified successfully is that you should mark that nullifier hash as used. And after that is when you should do whatever it is that you want the user to have happen after they verify with world ID. So that could also be marking their wallet address as verified if you want to reference that later. That could be going ahead and sending them tokens as part of an airdrop, right? That is where your application defines what happens now that you know the user's verified. So we have $20,000 in prizes overall. 10,000 of that goes to the 4 best overall projects. So $4,000 to first place, 3,000 to second, 2,000 to third, and 1,000 to an honorable mention. We have $2,500 each for the most creative use case, the best governance app, and the best public goods use case. And then a $2,500 prize pool. And in that prize pool, that is for projects that don't win one of these other prizes, but make a good faith effort to integrate World ID. Right? So if you just say that you integrated World ID, or have somewhere in your code a comment saying, this is where we put World ID, that's not going to have you be eligible for the prize pool. But if you make an actual effort to integrate World ID, right? If you have IDKit in your front end and some commented out code in your contract saying so we couldn't get it to work, that's a good faith effort, right? And I will be at our booth all weekend. I'm probably sleeping here Saturday night because I like staying up late working with hackers, right? So it's much more about like trying to use World ID Obviously, I want to help you get the integrations to work. That's why I'm here. But if you aren't able to get it to work correctly, you can still get some funds from that prize pool. And then, as I mentioned at the start of this, there's a couple new things that I'm excited to talk about here. The first of them is that just on Tuesday, we announced that the developer preview of WorldChain, our own OP Stack Layer 2, is now live. So if you want to apply for access to this dev preview, you can go to worldcoin.org/world-chain-preview. And this dev preview is more for protocols and existing products that want to deploy to WorldChain before general availability. But if you're interested in building on WorldChain during the hackathon, it might be able to get you access, but a lot of the protocols you'd expect to be there aren't there yet, and that's why we don't have any bounties around WorldChain so far. And then the next thing I'm really excited about, this is the first time we're publicly talking about WorldID mini apps. Mini apps create a seamless integration of WorldID incognito actions, sign in with WorldID, or in-app payments by having your application open in a web view inside of World App. These apps can be displayed on the World App homepage. They're discoverable by our 10 million plus World App users. And getting your app in front of 6 million verified humans around the world, it's a pretty good distribution mechanism for this industry, especially. If you want to learn more about mini apps and get early access, come see us at our booth. The team member responsible for them is arriving this evening. So I won't be able to help you until later this evening, but to learn more, come chat with us. Thank you all for your time. At worldcoin.org/Brussels24, you can see a Notion page that covers a lot of what I went over here, links to our template repositories, everything like that. And you can come find me at the WorldCoin booth at almost any time through 8 or 9 a.m. on Sunday. And then after that for judging. I have to sleep a bit.
Hey everyone, my name is Jared, representing the Polygon Labs team as Developer Relations Engineer. Just in case you want to reach out to me, ask me any questions, and for whatever reason you don't want to ask me in person, probably the best way to reach out to me is on Twitter. Just send me a DM and I'll be able to reply. But I'll be around like everyone else all weekend, so don't be afraid to come up to me and ask me any questions related to this talk or just Polygon in general. I'm happy to have a chat with you. So I thought about what I wanted to present at ETHGlobal, and you know, I'm an audience member a lot of the time myself, and I kind of find myself scrolling Twitter, messaging people, and not really paying attention to what's being presented because I don't know, whatever it is, like my brain rot or whatever it is, I'm just not paying attention. So I tried to keep it as like brief as possible. I think there's like 20 words max on the whole slides, and just link out to a bunch of resources that I've created to help you understand what the Polygon CDK is. So hopefully I can keep your attention for the presentation. All right, so just TLDR, like what actually is the Polygon CDK? It is our chain development kit, so CDK, chain development kit, and it is a way to build your own ZK-powered layer 2 blockchains, so specifically ZK EVMs. And the story behind it is essentially we open sourced our ZK EVM production mainnet chain around a year ago, and then we've been running it in production ever since, and we said, you know what, we already have all these components. We spent the time and research into ZK and the issues that you run into running a production ZK EVM. Why don't we just open source each of the individual components and create a kit to combine all of those components to make your own L2, just like the Polygon ZK EVM. The idea behind it is that you can kind of plug and play different modules like data availability. You can choose what type of ZK EVM behavior you want, like type 2, type 3, etc. And essentially just pick and choose and configure and customize each of the aspects of the chain that you want to build. But the kind of default behavior is it is essentially copy-pasting the ZK EVM and changing the data availability module to be a Validium instead of a rollup. But all of that is configurable. All right, so here's what we're probably all here for at ETHGlobal, is to make some money. So I put this slide nice and early. This is our bounty for the Polygon CDK. So you can see we have $8 grand US over 5 different projects. The first prize winning $3 grand US. So some money to be won. I wanted to put that nice and early to keep your interest up. All right, so with the CDK, like I said, the main goal is to build your own L2s, but the pathway to get there can be kind of split up into 2 different categories. One is with no code, so I'm going to show you a quick little demo of a platform that will allow you to ship your ZK EVM in just a couple of clicks. And then for our more hardcore devs, I wanted to show you how you can get started locally running all of the components like the sequencer, the aggregator, the bridge inside of Docker containers on your local machine, which is a bit more fun to kind of configure and customize the behavior of the L2. So first, I'm going to show you through the process to do it in no code. So you don't have to scan the QR code, but on my channel, if you just search my name or search build a ZK EVM, you should be able to find this on YouTube. And pretty much what I do in this video, and as I'm about to show you, is literally in like 5 minutes, you can launch all of the components required for an L2 in testnet. And if my demo works, I will show you that as well in this presentation, but just in case it doesn't, I have pre-recorded the exact step-by-step tutorial on how to launch your own L2 testnet and show you each of the components, and then also show you how to build apps on the testnet that you create as well. So just before I show you the demo, the way that this works is typically Polygon Labs doesn't run the infrastructure for whoever wants to build the L2s. We've kind of partnered with these implementation providers and kind of vetted expert teams who are qualified to launch these L2s and run the infrastructure for you and maintain that over time. So these are often called roll-up as a service providers or RaaS providers. And like I said, it literally deploys all of the components, the aggregator, the prover, the sequencer, bridge, RPC, and even the developer tools that you need if you're kind of kickstarting your ecosystem, like a faucet and a block explorer, et cetera, et cetera. All right, so my little man over here didn't quite fit on the screen, but what I wanted to show you now is one example of these implementation providers. And this is called Gateway, so I'm going to tab out here and make this little full screen. So this is Gateway, one of our implementation providers who can launch a ZK EVM with the Polygon CDK. And I want to show you how easy it is. I realize I'm not signed in, so I might have to do that. But I literally just click deploy. You don't have to get a credit card. You don't have to put in any personal information. All you need to do is just click deploy. I've just signed in, sorry. Click deploy, and I already have one, so I will show you what it looks like once it's provisioned. So it'll go, you literally just click deploy, you click through a couple of options. This is the default behavior here. And here is mine called, it gives you a little demo name, but these are all of the components that it deploys. So you can see I have my own RPC, I have my own chain ID, I have my own URL. Here is the information about the gas. So before you actually get to this page, you'll go through a couple of different configuration options and reach a point where you say, yeah, I'm happy with the configuration of the chain that I'm about to launch. And you'll reach this page after a couple of minutes of provisioning the resources required to host each of those components for you behind the scenes. So this is like the easy route, I would say, if you don't want to run it all on your local machine. But like I said, you get the bridge. You can actually go to this URL. I think this one is hosted. That doesn't look good, does it? That's the demo effect right there. But what you would hope to see is the bridge from the L1 testnet to your L2 testnet. Of course, the demo effect is in play here. But that is like the easy route, as I was saying. So this is really no code. And like I said, you just click through a couple of pages, configure the options that you want, like the gas settings, what L1 you even want to host it on is customizable as well. So it's pretty cool customizations. But the other route that you can go through is to launch everything locally on your machine as well, inside of Docker containers. So this is pretty fun. I've been playing around with this for like a couple of months now. And this video will show you the first hour. I know 2 hours is kind of scary, but the first hour is just concepts of like what is an L2, why would you want to make your own L2, what are the different configuration options like data availability, different kinds of provers, all these like fundamental concepts of stuff that you would probably want to know if you don't already, if you're launching your own L2. So that is also, you don't have to scan the QR code, you can just search that up on my channel as well. But that will walk you through what this is here, which is our Kurtosis package. So the Kurtosis CDK package is, Kurtosis is an open source dev tool that specializes in kind of orchestrating these containers for you. So you specify what steps you want to occur and how those pieces that you launch should interact with each other. So for example, in the default behavior, it will launch a local L1. It will deploy the rollup smart contracts to the L1. It will deploy the node containing the sequencer, the aggregator, the bridge from the local L1 to the L2. All of these components, and it'll kind of like sequentially go through them and build the relationships between each of those components. And then you just swap over to your Docker and you can view each of the components running, and then kind of shell into each of those instances. So for example, if you shell into the RPC, you'll be able to see all the requests firing off, the effect of how much each of those transactions costs in terms of gas, and you'll be able to track those transactions just from the logs running on your local machine, which is pretty cool, as you'll see in the video as well. So I know it sounds scary to run all of these components like the sequencer, the prover, the aggregator, but it's actually super simple. It's literally 2 lines of code with a massive caveat of having a bunch of stuff installed. So it assumes you have Docker and Python and a couple of like basic dev tools installed on your machine. And all you need to do is clone the repository, change into that repository, and the second command is the Kurtosis run command. So basically Kurtosis is a CLI tool. It's going to inspect a file that basically tells it what to run. And in our case, it's going to run each of those components, launch them, and kind of deploy each of the required smart contracts in sequential order. So yeah, like I said, to get started, massive caveat, you must have a bunch of stuff installed like Docker and Python, a couple of other CLI tools. But once you get it, your environment running, it's literally one command and it's going to deploy every single component instantiated inside of Docker containers for you. The one cool thing, I'm just going to check what, okay, so this is what I wanted to show you is like a preview from the video. And the reason I didn't do it live is because it takes around 15 to 20 minutes to deploy. And with the Wi-Fi, I didn't trust the the process to go very smoothly. So I just took a little screenshot of what happens when you run this command from the video, where I skipped through all the breaks and explain what's actually going on. So you can see in this example, it basically literally just goes step by step through. Here's every single thing that needs to happen when you're launching your own L2. So for example here, you can see this is adding the synchronizer. It's deploying the smart contracts. It's then going to deploy the components of the node, like the sequencer and the aggregator. And basically, it just goes step by step, prints out the logs of what's happening in that deployment process. And at the end, you'll get either a big, giant red error message that says what's gone wrong, or you'll get a green error message to show you here's the Docker container IDs of each of the services. And I think what I wanted to go through before I know I'm going back and forth, sorry. This params.yml file is like hundreds of lines of configuration options. So there's a couple of config files like params.yml that you can configure how often you want to post batches of transactions to the L1, how often you want to post proofs to the L1, what the gas limit is, like what token you want to use for gas. There's like hundreds of lines of codes, hundreds of lines of configuration flags in this one file. And then you can even go deeper and configure the behavior of each of the services, like the aggregator and the prover and the sequencer, and configure pretty much like at a very granular level what's actually going to happen when you run this kurtosis run command. Cool. So I just put this here at the end. I know it's kind of like scary, but I wanted to talk about what you're actually shipping. So I keep yapping away about all of these components like the sequencer, aggregator, etc. But what actually happens when you run this command is you pretty much instantiate all of these pieces. And this is even simplified of what you launch, so there are a lot of moving pieces. But what's going to happen is you launch first you launch a local L1, but you can also swap to Sepolia, which is what I do in the video. You deploy these smart contracts here. So basically you deploy a roll-up smart contract that is responsible for receiving the batches of transactions as well as receiving the zero-knowledge proofs to verify those batches of transactions. So the steps are deploy the L1, which is optional. You can choose to deploy to Ethereum testnet if you are rich in Ethereum testnet funds. You then deploy the bridge smart contract, and then essentially, I'm simplifying it here, but you deploy a trusted node and a trustless node, which contains the aggregator, it contains the prover, and it contains the sequencer here. So the sequencer basically reads these transactions from the L1, takes them in, executes them. So it's like, is this transaction complete garbage? Is it a duplicate with another transaction in the pool that's been submitted? Is it going to conflict with another transaction in the transaction pool? Basically, it just does a couple of sanity checks and then executes them or discards them. And then it gets sent, so there's a kind of sub-component of the sequencer called the sequencer sender, I think. And that is going to send the batches down to the L1. And then this kind of second process gets kicked off where the aggregator says, hey, I see you've got some nice looking juicy batches for me. Let me go ahead and prove those. Sends it to another component that you've deployed inside another Docker container, who proves, generates a zero-knowledge proof, sends it back to its buddy, the aggregator, and posts it back to the smart contracts that you've deployed on the L1. So there is a lot more pieces like the bridge and the RPC and the block explorer. And out of the box, you also get this awesome stuff to kind of inspect what's going on, to see how many people have bridged, how much funds have been bridged, the block time, the time that has elapsed since you've last proven the blocks. All of this cool information is kind of ready for you out of the box just with these two commands that I showed you in one of those previous slides. Nice. So one of my goals before coming to ECC was to ship some new CDK docs. So I just chucked this right at the end to say we've just shipped like a week ago, new overview page, new getting started, new concepts, all brand new fresh docs ready for the hackers to kind of play with in case you're sick of listening to me in these videos as well. You can just read the text. It's pretty much exactly what I'm doing in the videos, is just going through the process in these documentation. So yeah, that's pretty much all I had. Like I said, very text light, so hopefully it kept your attention, but yeah, $8,000 available to be awarded for projects building their own L2s. I've been saying to a couple of teams already, some strategies for teams is to ship a cool product, build it on a couple of different L2s. Why not slap on your own L2 and ship it there as well? It's, like I said, very, very easy to do. But if you want to go more granular, get some cool customizations, you have a cool idea for creating custom L2, you can experiment with the local deployment as well. Yes, Mr. Blake.
Since we only have one weekend, the time is ticking, I guess. Do you have any recommendations as to where to start, since there are a lot of cool customizations? There are a lot of ideas floating around there. What would be the best place to start for a team to discuss, ideate? Is it getting into the customizations, and where should I start if I do that? Or if I'm looking for a big picture product? Yeah, I think one thing is this is a very amazing bounty, but quite like you could get into the weeds. So is there any recommendations on the strategy into going in your hackathon project?
Yeah, so just to repeat for the stream, the question is like, what's the best resources to get started with the CDK for the hackathon? I think there's a couple. I think the obvious one is just come speak to us, like see if your idea is feasible, if you have a crazy one, if you run into any issues, like just come and speak to us. I know some of us are a bit scary, but no, we're very, I'm super keen. Like I've been working on this for a couple of months trying to improve the developer experience, so I would love to hear if you think it's complete garbage. Please come and tell me. If you can't get anything running, please come and tell me. What you should also do is we have a ton of our engineers who are about 100 times smarter than I am in our developer Discord, or our R&D Discord. So you can jump into our Discord server and speak directly with the engineers that actually built the tools that I'm trying to shield to you here today as well. And I mean, if you take it a step further, we also just shipped our grants program. So, I mean, there are kind of pathways to develop this more seriously if you're looking for kind of financial rewards after the hackathon as well. So happy to come and talk about that at our booth too. Yeah, round two.
Yeah, are there any use cases that you would recommend to the hackers of like, solutions, problem statements that like you would like to see solved? Or, right, someone could go off and just make something crazy, but is there anything that is like that's inspiring, or sort of like I can start here, I'm solving for this problem that you know of or you want to share?
Yeah, I think there's like you said, there's options to go completely off the deep end and try and ship something combining, I don't know, maybe like you could combine one of the DA tools that is here and ship a new roll-up with a different DA tool. I think a cool one that's pretty simple to customize is like changing the gas token of the L2 that you ship. So something that would be sick would be like if you launched your own L2 with USDC, or something like just kind of one simple change that doesn't exist today. For example, changing the gas token, or changing what where you send the data to, or things like this. That it is approachable. You could go completely off the deep end, but within 36 hours, I realize it's probably a lot to ask to go too crazy. But yeah, like I said, I think the best approach would be pretty much just come and talk to us, see if your idea is feasible. The whole idea of this is meant to be customizable, so we're keen to see pretty much anything that people come out with. And if you think, like I said, it's terrible, it sucks, I don't want to use this anymore, that's also amazing. Please come and tell us so we can improve it for future iterations as well. Sweet. No more questions? Awesome. Thank you.